Hi everyone. First, thank you for investing your time in checking out my talk. Second, I'd like to extend that thanks to the NI Dev conference organizers. This event is a key part of the calendar in the NI software landscape, and I'm happy to be a part of it this year. So you may look at this title with a perception of portraying something bombastic. However, there is a lot of nuance in how you build and scope your teams, whether it is AI or any other software discipline. AI is a fascinating, rapidly moving territory for both opportunity and dynamic skills advancement. So it's essential to step back and take a strategic approach to shaping internal capabilities in this space. The intent is this talk will offer a mature, helpful perspective, giving food for thought as we explore these topics. So we know the world continues to change, both in predictable and non-predictable ways. I'm going to refer back to examples from the past with the hope of informing the future and offer an antidote in your planning. This will be the core topic. Should you embrace specialist AI skills? Numerous factors influence this, but I will take an opposing viewpoint and hopefully inspire more depth in this conversation. I'm going to frame my discussion around viewing AI skills as a horizontally wide skill set, as a discipline that is requiring increasingly varied foundations of skills and talent to really meet business demands. I also act as my own devil's advocate. My viewpoints continue to evolve based on my experiences and learning, and I believe it's key to address alternate viewpoints. But we should pause, and I should introduce myself, shouldn't I? So my name is Jordan McDonald. I have a skill set that is shaped to something I would refer to as a Frankenstein of different components. I'm trained as a software engineer, but I've always worked with building, integrating, and deploying AI solutions, both in the public sector of Kainos to the private sector in the insurance space. My current employer, Allstate, as a machine learning engineer. As a fun fact, I joined Allstate the week of the UK lockdown, so I've yet to step into the office. So rather than shaking hands and having lunches, it's been video calls and conversations online, trying to build connections, which has been a fascinating experience. So keynote on my general ML experience is I review the world of AI a little differently than those with more traditional math or stats backgrounds. To this end, I feel it's worthwhile to explore how the role of the data scientist has changed over time and how that relates to my core hypotheses. So now what we're going to do is we're going to step into a time machine and look at the past. My perspective is one that is tinted by 2020 vision of looking back in time. But I want to try and draw parallels to both the development of AI as a toolset in the software and its associate role closely aligned to it, the data scientist. I'm going to try and use this flash through time to mold the first phase of my argument, which is essentially the value of generalism over specialism in AI being the ideal aim for the majority of organizations. First, let's crank the dial in our time machine back to 2010. This is when the Burj Khalifa was inaugurated, Deepwater Horizon oil rig explosion occurred, and the public launch of Instagram. Time flies, right? This is also when Drew Conway, notable data scientist, who also did quite a lot of work in the social science space as well, created this data science Venn diagram. He imagines the role as a combination of hacking skills, which in this context for him means problem solving or inventiveness, a backbone of maths and stats, and know-how and expertise being the thing as the final overlapping dimension, both in your domain and target working area. This diagram is often referred to as a sound conceptual representation of the classical data scientist from the start of the decade. As we know, skills, tools, demands, and the people working in this vortex of change have to adapt. So indeed does any given role. In 2014, this was the year of the Brazil World Cup and the Flint water crisis in the US. Even 4 years on, 4 years closer to our time, it feels like another world. This is quite early in my working career as well. Stephen Geringer added another encompassing dimension to this Venn diagram, proposing that any variation of computer science, math, or stats, and SME knowledge all lived within the sphere of data science's influence. The core idea was this: if you're managing, manipulating data in any form, you live in a data science world. This, I feel, introduces and formally defines more nuance, solidifying a core idea of specialisms of the role being adopted and being given greater awareness. If we hop back into our time machine, take a look at the year 2017. This is when Donald Trump was sworn in as US president in early January. In this diagram, we see the scope and range of skills in the data science world continue to expand. In a tangible way, really begin to splinter as well. At this time, it is a very common practice for organizations to have clear distinctions between data analysts, data scientists, and even decision scientists gaining popularity. More so interesting for the hypothesis of this talk is the emergence of the ML engineer, or AI engineer, depending on what flavor you want to use for the term. So even before I knew it, this is the role that was shaping and would continue to shape my career. As a constant observer of both the technical and organizational change in ML space, around this time is when we began to see the ML engineer role itself morphing to demand specialisms. Vision engineers, NLP scientists, deep learning experts, on-device AI specialism, and even extended object detection wizards. So if we had to sum up in a single word what exactly is happening right now in the world of AI practitioners, I would say specialism. AI is a vast ocean of ideas and expertise. It is impossible for any single person to know everything to a level you can practice and justify mastery. Mastery, I feel, is a key motivator for the most talented engineers in the world of software that I have worked with, especially, as we strive to develop and become true craftsmen in the space. But if you're a junior starting your AI journey, or someone with several years of experience working with AI, the fleeting concept of aiming for mastery becomes increasingly difficult, I feel. This is compounded by organizations truly valuing the transformative power and potential of AI, and AI education becoming the default now among business leaders, leading to increased demands on existing teams to be able to handle an increasingly varied tapestry of projects. So we know the role of the ML engineer is going to continue to splinter. Is there any scope to look to the past to help inform our future decisions, both as people and as companies? I feel we could learn significant lessons from the ever-changing story of JavaScript frameworks. I think we could draw eerily similar parallels to the role of these frameworks and ML roles and tools. On the left, I've plotted an approximation of core releases from AngularJS and React. Pay particular attention to the date ranges. Activity here is skewed to the earlier half of the decade. If we refer to the Google Trends for both of these frameworks, we can see that AngularJS soared in popularity in the years following its release, but plummeted towards the end of the decade. We have to ask ourselves, why? There are myriad reasons for this, but one such is the rise of alternatives, capitalizing on the imperfections of AngularJS and the fact that, especially in the world of JavaScript, constant evolution and improvement toolsets does occur. We can see this reflecting the growth and popularity of React. With this perspective in mind, it's common knowledge you cannot expect a JavaScript or front-end engineer to know every tool or technique inside and out. This has led to, well, it's our good old friend specialism. If you did not know where I'm taking this topic, this should hopefully start pulling away the wizard's curtain. But how does this really map to the world of AI? Let's perform a similar comparison, this time with two popular Python ML frameworks, TensorFlow and PyTorch. We can see that TensorFlow's popularity has stalled, while PyTorch continues to soar. It is too early to predict the future of these tools, but PyTorch's fantastic intuitive API is one such reason why it's so popular. Early TensorFlow could certainly not claim that advantage until they released TensorFlow 2. You'll note these tools have gained popularity in the second half of the decade. So you'd imagine they're a few years behind the JavaScript analogs that we refer to, Angular and React. My prediction is we'll see a similar pattern of tool popularity conforming to specialism, as we've seen for TensorFlow experts, NLP scientists, and vision engineers emerging. For me, it's TensorFlow that needs to watch its back. This is one reason why doubling down on certain skills and frameworks as an organization is inherently dangerous. You need to remain adaptable and be prepared for your viewpoints to be at least challenged, and in some cases demolished. You want challenge, not demolition, so embrace flexibility. The core lesson in this is you want to predict the future, you first have to understand the past. AI does not exist in a vacuum. Step back, look at the abstraction of software and people first. This brings me back to my core hypothesis. In the world of AI in 2020, is it better whether you're an individual or an ML team to embrace specialism or aim for generalism? Let's explore this further. If I step back and look at the world of machine learning skills from 20,000 feet, what do I see? Well, I see an ice cream shop. At the root, everyone working in ML is a type of ice cream. We all live in the same world, and we all share the same core values inside the shop. But I see significant variation in the flavor of roles that are manifesting in the real world. We can view the tapestry of skills in the domain of ML engineers as a radar plot. This is one of many interpretations, but it reflects a visualization I find quite intuitive. This represents a subset of the demands that can be placed on you as an ML engineer. This varies across companies, business needs, and cultures. You may be shocked to see topics such as API design, CI/CD, and design patterns in this taxonomy. More and more ML engineers are being looked to as the glue of an ML project, living within multidisciplinary teams composed of testers, ops, and software engineers. As that shepherd of the ML piece of the project, protecting the core engine, the model, you need to have the ability to appreciate all of these skills, and that skill is increasing in demand. If we take this framework and apply my ice cream analogy further, how does this manifest in the real world? What flavors of ML practitioner am I seeing? This profile of skills, I believe, reflects a typical data scientist, or at least a potential stereotype view of a typical data scientist, which to some extent is reflected in my own experiences of the past several years. A strong core skill set on data science fundamentals and statistics, but typically weak in regards to code quality, design, testing, and performance, and even essential deployment paradigms like containerization tools like Docker. While this skill set in the grid does not look outright flattering, these people are highly valuable, and they play a key role in machine learning teams. Evolution and change cannot lead us to forget the core principles of data science that underpin everything in AI. In today's world, we're seeing an enormous influx of those trained and practiced in software engineering transitioning into AI roles. This profile of people often offers a different but equally valuable skill set with an appreciation for good software development principles while having enough of an AI skill set to take responsibility for less complex data science projects or collaborate well with more developed ML leaders. As ML teams continue to own end-to-end process of a prototype to deployment and support, this type of person is equally as important as the hardened data scientist, offering perspective on performance and really bring to life one of my core goal mantras. And I'll say it again, AI does not exist in a vacuum. Popularity for NLP scientists is really starting to grow. This makes a lot of sense. If you're a company who leverages text data in a major way, you want a degree of specialism to fully realize business value for your AI opportunities. The same idea extends to computer vision. Just an example of a precise type of specialization. And in Northern Ireland, I think there's very few people of this type around. So in opposing or contrast, there's a skills profile that I value highly compared to something as niche as this. This is the profile of the well-rounded ML engineer, someone who avoids direct specialism in an ever-changing world, but opts to combine and squeeze the important fundamentals of the core tenets of engineering, data science, and operations. Or some people may refer to this as a unicorn. 5 years ago, certainly. But in the past 5 years, we've seen a lot of changes in tooling and abstraction that have really begun to change the game. Reducing barriers to entry in some cases, which really free up an individual's development of skills in several areas rather than just one. People who fit this profile, I feel, are highly valuable. They blend with excellent soft skills, especially, and you have someone who can really build up as your next generation of leaders to really help drive your business in regard to AI for both now and in the long term. Finding individuals who fit this profile is even more rare, I have found. But this is why it's key to create blended teams, which give you balance across this radar plot of skills. So you might be thinking, why is my view on aiming for generalization important? I think there's a core trio of people this helps. The individual, it'll aid in your career. It'll give you flexible selection of roles and opportunities you can aim for, future-proof your skills. It can help teams and the long-term health of an organization, building your people in a manner that can account for the uncertainty of the future. There's also several other important, tangible reasons that I want to highlight, and I'm going to focus on 4. A well-rounded engineer in the ML space can communicate horizontally across your organization, effectively taking into account and collaborating with all your technical teams, becoming the glue that shepherds an ML project through its development. Adaptability is crucial. As we have discovered, tools change and more importantly, so do business needs. You want to have people who are not rigid and embrace the sense of lifelong learning. This is critical in the fast-moving world of AI, especially as things like AutoML begin to slowly mature and may change the paradigm to an extent. This third point echoes that point. Are you sure you really want the TensorFlow engineer, or do you value a core experience set across multiple tools? Select the right tool for the job. That is a key tenet in multiple industries. But to do that, you need to know what all of the tools are. This applies equally to DIY as it does to the software industry. Ultimately, what do we want to build? Software we can trust, software which protects data, and software that meets a business need. You want people who appreciate this spectrum. It is impossible to know everything, but you can at least offer an appreciation of non-functional requirements, deployment constraints, and to really avoid investing time into building a lemon, an AI model that is not useful in the real world. State-of-the-art outcomes are often not the most important goal. Before I move into the conclusion of this talk, everything I've covered here is acquired through a range of anecdotal, historical, and experience-based sources. But I, like everyone, lives in a fog of war. Nobody knows what the future truly holds. But it remains crucial to try and pierce the fog, try to anticipate the future, and as a business leader or a team lead, it is your responsibility to do so, and it should frame your strategies. Tea leaves are bogus, but we're referring to evidence and experience and history that has tangible value. This is what separates artful prediction from speculation. Finally, I want to thank everybody for listening. The metaphor of the panda surrounded by bamboo, I'm sure, is not lost on any of you at this point. I hope you all have a great NI Dev conference, and if you want to reach out to me, send me a message on Twitter in the top left-hand corner. Whether you want to discuss what I've covered here or chat AI in general. Thank you for your time.